This now is kind of a fun topic, which is a follow-up to our previous video on induction and the least number principle. The question, which positive integers do you consider interesting? Different people have their own lists of interesting numbers, and some of them you can find online. I won't try to duplicate other people's choices, but just for an example of the kind of thing we might look at, there are 5 Platonic solids shown here, and the number of faces on the Platonic solids are 4, 6, 8, 12, and 20. Since there's only 5 Platonic solids, you're stuck with just 5 numbers here on this list, and this is arguably something interesting to include on a list of interesting numbers. I would personally consider the number 23 interesting, for example, for mathematical reasons, because of its connections with the Leech lattice, the Mathieu groups, and the binary Golay code. If you don't know, the astonishingly good photographs taken by NASA's deep space missions with the Voyager and Mariner spacecraft, for example, they rely on the binary Golay code, which comes from the number 23. I'm passing over lots of good examples of interesting numbers. The list would get pretty long if I tried to include all my favorites, but you're already probably getting an idea, and I can't resist mentioning here one of my all-time favorites. This number's extremely special because it's an integer which passes extremely close to this transcendental number, coming within 12 decimal places, as this computation shows. And this is not an accident. It happens for very particular number theoretic reasons, which I can't go into here. And this fact is related to many other special properties, like of the number 163, which, by the way, would also be included in my list of interesting numbers. It's easy to identify special properties of smaller numbers. Once you get to larger numbers, then presumably the interesting ones start to get sparse and spread out. Still, there are a lot of larger numbers that I would call interesting. And this one, for example, is the order of the largest sporadic finite simple group. So you're not going to find any other number that has this same property. This is a number that arises in group theory, so in algebra. I'm not sure really if this number is truly interesting, but at one time, the famous physicist Sir Arthur Eddington declared his belief that this is the exact number of protons in the universe, also the exact number of electrons in the universe. I don't think anyone today really believes this statement because, for one thing, the number of electrons, we believe, is not a constant. It fluctuates all the time as particles are transmuted into energy and back into particles without ever stopping. But we do believe the number to be at least in the right ballpark of this Eddington's number. This number is much too long to write out fully in decimal form, having over 23 million digits. But at the time of recording this video, it is the current record holder for the largest known prime. This record will almost certainly be surpassed within our lifetime, maybe more than once. But since there are so few Mersenne primes known, only 50 of them so far, these numbers will continue to be considered special. Here is a tongue-in-cheek proof that every positive integer is interesting. To understand this argument, you need the least number principle. Let S be the set of all positive integers which are not interesting. We claim that this set is in fact empty. Suppose by way of contradiction that S is non-empty. If so, then the set S must have a least element, which we would call M. So what is M? M would be the smallest positive integer which is not interesting. Well, that's a pretty interesting number. Contradiction. I will leave it for my students to talk about, so I'm not going to give any more comment about the argument here.